Hello students, welcome back to the 7th video of this playlist. In this video, we will be discussing the 16th question of the most recent past paper of Physics Unit 2, which is the October 2024 Physics Unit 2 paper. So let's get started with question number 16 of this paper. So here you can see the question number 16. So here the question says, a student investigated the diffraction of light from a laser using a diffraction grating. Okay, the diffraction grating has 250 lines per millimeter. The diagram shows the arrangement used. Okay, so here we can see the the diagram of the arrangement. A laser light. It has been directed on a diffraction grating, and then the light will diffract as it passes through the grating, and a diffraction pattern will be seen on the screen. Okay, so part A is asking here to give one safety precaution to the student should take during the experiment. Okay, one safety precaution. So the most probable safety precaution in this case would be, we know that laser light, it has thin beam. It has a very thin beam, and it since the beam is thin, therefore it has very high intensity of light, right? So in that case, if the laser light it is incident on someone's eye, then the person will feel uneasy or uncomfortable. So one safety precaution we can say in this case is that direct the laser light away from people's eyes. This is one safety precaution we can say for this investigation. Fine. Okay. Next is part B. In part B, the question is asking to state what measurements the student should make to determine the wavelength of the light from the laser. Okay. So the wavelength. We know that the formula for diffraction grating, it is basically n lambda equals to d sine theta. So n can be found from the number of the order that has been considered. Lambda we should calculate, and d can be found from the leveling on that grating, and so only remains it is sine theta. Okay, so that means we need the theta. So this theta, the angle, it is basically the angle between the central maxima and the and any other order. Okay, any other maximum order. Okay, so in that case, to calculate theta, we need the distance, the direct distance between the diffraction grating to the screen. Okay, so this should be measured because theta equals to, for theta we need this direct distance. If I show you using dotted lines, look, we need this direct distance, and we need the distance between uh, the central maxima to any other maxima. Okay, any other order of maxima. So this is the theta, right? So at first, the student should measure the distance between the central maxima. The student should measure the distance between central maxima and any other maxima. Okay, so you will get this distance d. Okay, 2 marks. So the second point, secondly the student should measure the distance between between the grating to the screen, because for calculating the theta we need these two distances, that is x here. Okay, so that we can use tan theta to get the angle theta. Okay, so that's the answer for part B. Fine. Okay, next is part C. Okay, in part C, the question says the student observed the two first order maxima. The angle between the two first order maxima was 18 degree as shown. Okay, so we can see in the figure the angle between the two first order maxima, it is 18 degree. Okay, show that the wavelength of the light from the laser is about 600 nanometer. Okay, so n equals to 1 here because we are considering the first order. So lambda equals to d sine theta, right? So we need the value for d. Okay, so sine theta can be found using the tan theta. Using tan theta we can figure out the angle theta, and then we can get the value for sine theta. Okay, fine. The diffraction grating has 250 lines per millimeter. Okay, so therefore the value for d there, so 250 slits or lines, whatever you say, slits are there in 1 millimeter. Okay, so we need the width of a single slit. So one slit, it is in 1 over 250 millimeter. Okay, so this is 1 over 250, that much millimeter. So 1 over 250 millimeter can be written as in meter. We can write 1 over 250 over 10 inverse 3. So you will get, okay, wait, 1 over 250, it is in millimeter. This is the width of a single slit, that is d. So 1 over 250, we have to divide it by 1000. So you will get 4 times 10 inverse 6, 4 times 10 inverse 6, that much meter. Okay, now theta here, okay, theta here, okay, we don't need to use tan theta here because theta would be just half of the given angle. Okay, the theta should be the angle between the central maxima to the first order maxima, right? So this is half of 18. So theta, it is equals to 9 degree. So lambda equals to 4 times 10 inverse 6 times sine 9 degree. So that would give you sine 4 times 10 inverse 6 times sine 9. It is basically 6.257378602 times 10 inverse 7, that much meter. So if you convert it to nanometer, it would become 625.73788602 times 10 inverse 7, that much 10 inverse 9, right? 10 inverse 9 meter. So we can write it as 600 nanometer short. Okay, that's the answer for part C1. Fine. Okay, next is part C2. Okay, here the question says the student observed maxima beyond the first order. Determine the greatest order of maximum that the student could observe. Okay, so the greatest order. So we know that the angle theta corresponding to the greatest order, okay, it is basically 90 degree. That is, if you consider the greatest order maxima, so the angle between that greatest order maxima and the central maxima, it is maximum 90 degree. Okay, so we will consider theta equals to 90 degree for the greatest order. Okay, so we have the theta, we know the value for d. This is 4 times 10 inverse 6, 4 times 10 inverse 6 meter. And using these values, we also know the lambda. Using that, we will find out the value for n. the maximum order. So n lambda equals to d sine theta. We also know the value for the theta, 90 degree. Sorry, 90 degree. Okay. So n would be d. The value for d is 4 times 10 inverse 6. Okay. Times sine 90 degree. It is 1 over lambda. So lambda is basically 600. Okay, 6.25. The exact value. Use the exact value times 10 inverse 7. That it has no units. Okay, that many orders. Okay, 4 times 10 inverse 6 divide 6.257378602 times 10 inverse 7. So if you divide, you will get 6.39245 something. So that means uh, there are 6 complete maximum orders you can see. Okay, so 6.392453221, that many orders. Okay, so greatest order of maximum, it is exactly 6. Okay, we can see exactly 6 order of maximum. Okay, and that's the answer for part C2. Fine.